Excuse me, where should I put my items at the rummage sale?
What are they?
Just a big box of CD-ROMs.
Specifically AOL free trial discs.
Oh, that would go with the clutter someone might find interesting section near the secondhand IBM 650. You can just set your box next to Rear Admiral Hopper's box of nanoseconds.
What charity is this for, anyway?
It's called Feed the Hungry Unicorns. Don't worry, I checked it all out. It definitely isn't a scheme by the unicorn to get more food.
This season of the Bug Hunters Cafe is made possible by Sopterific, Mousepaw Media, and... I don't think it understands me.
See, I told you that old electronic translator wouldn't work.
This charity rummage sale is amazing. Look at all the books I found.
I'm sensing a theme here.
Yes, I love books.
Well, yeah, besides that, the books you have there are all about Frontend. Aren't they all going to be out of date by now? I mean, they were published in, what, the last 3 days?
Not this one. It was printed 2 years from now.
2 years from now? You know you're not going to be able to get that through the portals, right?
Oh yeah, I forgot. I know, we can talk to Cecelia Martinez.
Oh, yeah, she'd be great to talk to about this subject area. After all, she's written lots of articles about JavaScript and TypeScript. She volunteers with Women Who Code Frontend and with Out in Tech.
Well, sure. But more importantly, she's a time traveler. She's the community lead at Replay.io. It's a time-traveling debugger from the future. So she's like Hackerman, only way cooler.
I don't think that's how it works.
Hey Cecelia, we're over here.
Hey, nice to see you.
I found this great book on JavaScript framework that won't be vetted for 3 more years. How can I get this through the causality filter on the portals?
Well, I think with JavaScript, even if it hasn't been invented for 3 years, there's probably somebody out there who's trying to use it anyway. So I think there may be some wiggle room because I've seen a lot of unique implementations for JavaScript front end. So we can see, you may have some luck with that.
Yeah, considering how quickly JavaScript changes, I'm worried that this book is already outdated.
Yeah. Is it specific to any particular framework, or is it just vanilla JavaScript, as they call it? Ooh, vanilla. That sounds like something tasty I might want to order.
Well, actually, that reminds me then, can I get you anything to drink? The coffee's on Sopterific and Mousepaw Media. They're sponsoring the talks.
Oh, yeah, then absolutely. Yeah, so vanilla sounds good, but I think I like to kind of dabble into a lot of different things. Let's do vanilla. Let's add some hazelnut and some cinnamon in there also. Just get all the flavors. I don't discriminate on flavors or frameworks. So
that sounds good. You know, hey, if you look at the back of your book here, Bojan, they actually call the framework hazelnut. Interesting.
Ooh,
yeah,
I want that.
I'll get your order there, Cecelia. And do you want the usual? Would you like some hazelnut added there, Bojan?
Yes.
All right, I'll get your usual with hazelnut.
Well, Cecelia, when I started working with programming, I had to do a little bit of front-end programming. And that was super scary for me because there were event loops, bunch of callbacks, we didn't have debuggers, we only had vanilla JavaScript and jQuery. And that experience left me a bit traumatized. And what's weirder, all 3 of my siblings are front-end developers. So I feel like I did something wrong there. Can you tell me more about front-end development in general?
yeah, so when I started with building websites, it wasn't really called development back when in the day. It was kind of websites were kind of more simple. Web apps have become a lot more complex over the years. It was HTML, CSS, JavaScript. I've also used jQuery before too in order to easily leverage functionality. And that was really all you needed for a long time, right? And as the years have gone on and more people are living on the web apps have obviously gotten a lot more complex. And that's where you start to see frameworks come in. And so as a front-end developer, I use a lot of different frameworks, but underneath the hood, they're all JavaScript. So understanding not only the intricacies of the abstraction that you're using, but the underlying JavaScript can be a fun adventure, especially if you kind of work across different frameworks and everything. So it sounds like maybe it runs in your family, front-end development. I would say it requires some flexibility and creativity and a high tolerance for trial and error, especially when things don't go as planned. So,
Yeah, for me, that was the strangest thing about JavaScript. In Python, if it works, it works. In JavaScript, if it works at that resolution, on that browser, on your machine. How do you make sure that everybody is having the same experience?
yeah, so that's tricky, and a lot of times people don't, right? And so I kind of talk about how JavaScript is a little bit like the Wild West. So when my very first software development position, I actually was working with C# and .NET, and then an Angular JS on top of that. And so kind of going back and forth between C# and then JavaScript, you can get away with a lot in JavaScript, but sometimes you need boundaries because you can do too many things. You may not always do the right things. And having a seamless experience for all users is something that is really challenging and a lot of frameworks try to accomplish, but it can be tricky. I mean, one of the things that I have done as well is I worked in testing. So I was at a company called Cypress, which does software testing framework for web applications. And cross-browser testing was a really big aspect because it may work in one browser, but not another, or it may work in a web viewport, but not a mobile viewport. And then all the CSS starts to break down. And so essentially trying to, have reusable components that will work across different browsers and different viewports is something that front-end developers specifically struggle with for sure. And testing can help with that, but, there's bugs do get out there for sure.
Hey, I've got your orders here. Here's your usual Bojan with hazelnut, and then they had a future framework frappe. So I hope that'll work.
Perfect.
It's exactly what you were hoping for. Vanilla, hazelnut, cinnamon, with just a sprinkle of TypeScript in there. So I have no idea what TypeScript tastes like, but I mean, it's is it any good?
Yeah, it tastes like sweet boundaries. So it adds just enough rigidity to otherwise a little bit of a chaotic drink, I think. So
Okay, yeah, that's good. So I guess it's a bit of an emulsifier then.
yeah, absolutely. It just kind of blends everything together and helps it go down a little smoother. So
yeah, I've played around with. I have a love-hate relationship with JavaScript. I hate reading it. I love to hate it, but I love writing it because it's so filled. I have a weird addiction to undefined behavior. I really enjoy debugging undefined behavior and then writing things around to avoid undefined behavior. And JavaScript is undefined. Well, I've made this somewhat uncharitable comment before that JavaScript is just controlled undefined behavior. At least the original. I think it's getting better. But how do you, especially coming from languages that actually behave according to the laws of physics, how do you get used to JavaScript and work with it without losing your mind?
yeah, so one of the things earlier this year, actually, I saw a talk by Jen Creighton, and she talked basically. It was about debugging async JavaScript specifically, which is one of the complexities that you have to deal with JavaScript. And one of the things that you talked about is how you don't know what you know until you know it. So you don't know something until you know it. And I think that JavaScript is a lot like that. There's just some quirks that are built in. And until you encounter it in the wild, then you just aren't really going to know it. So to get around that, I found that if you approach issues with a good process and you know how to use your tools right, then when you think something's going to do something and it does not do that, then you're at least better equipped to start figuring out why before you get to the point where you just know everything, which is never. So, especially with JavaScript.
So what is that process? At least for you, what is that good process?
Yeah, so it may vary depending on the developer. So one of the things that I've done is actually I've talked to a lot of developers about their debugging process. Well, I didn't know at first that I was talking to them about their process. I just started by having them walk me through how they debug and asking them how they approached it. And over time, started to kind of pull some patterns out from what they were doing. And it's honestly with the developers who have a good process and who tend to have more fun debugging or debugging issues, or at least are able to be a little bit more efficient with it. It's because they're approaching it with a little bit more of a scientific process. The first step, though, is knowing what's wrong. And in order to know what's wrong, you have to know what right looks like. And so understanding your application and what it's supposed to do is typically a first step. So that requires some familiarity with the code base and kind of what your application is supposed to do. Beyond that, it feels a little bit like the scientific method, right? You may have a hypothesis or two, but you don't want to get too stuck to it. Reducing the scope as much as possible. So I like to think about how in front end, because it becomes so complex, if you click a button, right, like an add to cart button on a shopping cart site, and the quantity does not increase, nothing shows up in your cart. There are so many steps that are happening where something could have gone wrong. It could be that you're not emitting the events from the button up to the framework. Something's gone wrong with the dispatch into your state management. It could be that the API call that went out to check and see if there was quantity and didn't return the right response. There's so many different things that could have gone wrong. And so isolating the problem and reducing the scope as much as possible so the problem becomes smaller to solve. And then using your tools to just trace back through the code execution. If you can throw some time travel in there, even better. But I started to see this pattern emerge with people who would walk me through their debugging process, where it was a very intentional approach and not kind of just trying a bunch of things and seeing what sticks, which is what I tended to do a lot of times when I first started debugging. So.
Yeah, you mentioned a time-traveling debugger, and Bojan mentioned that too. I mean, I see you have a temporal displacement device on your wrist there, which, cheap and nasty time travel, but hey, it works. But, so how does someone who doesn't have that type of technology do this time-traveling debugging?
Yeah, so, you don't have to be a time traveler to time travel debug. You can use specific tools that will help you do it. I know, I'm a little bit more maybe of an advanced user of time travel for debugging. But essentially, when we talk about time travel debugging, you're going back in time to when the bug actually occurred and rerunning through the code execution to see what happened. And so if you think about a time traveler versus an archaeologist, normally, when you're debugging, you're an archaeologist. You may have artifacts, you may have some logs, you may have, some stone tablets with some output chiseled on it that you have to piece together to try and figure out what happened, versus actually going back in time and watching the event unfold in front of you. And that's what time travel debugging is. It's using tools that allow you to essentially record what happened to be able to go back and replay it and revisit it and step through that moment in time.
So does this mean I can be called Indiana Jones of programming?
Absolutely. Absolutely. I actually refer to myself as Indiana Jones pretty frequently. But there is more and more, though, I've been drawn to going and seeing it live. If you think about going to ruins versus actually like walking around and the palace itself, in its glory. Once you kind of get used to that, dealing with bones and stone tablets and artifacts doesn't hit quite the same, but it can still be very fun. And you can still have the cool jacket, hat, and whip. So
My line of work, I just get to wear a bow tie and a fez.
Oh, well. But regarding time traveling, that sounds like a super useful tool for debugging, but every time I start thinking, how can you implement something like that, especially due to difficulties you mentioned in JavaScript, component, bunch of asynchronous calls that are happening. JavaScript sounds like a language where time-traveling debugger would be even harder to implement than it would be normally.
Yeah, there's a lot that happens with JavaScript, and especially when you think about web applications, because it's also interacting with, HTML and CSS as well in a browser. And so one of the tools that I like to use, it's called Replay. It allows you to essentially record a runtime. One of the most common uses is recording browser sessions, because I'm a front-end developer. And it records all the JavaScript execution that took place, but it also records my HTML, CSS, my components, props, and state at different points in time so that I can better inspect them. And the interesting thing to be able to see is that you're able to see how many times like each line of code executed and jump to those points in time. Especially when you're working with frameworks, I have found that when you have things like component mounts or hooks that fire off, for example, if you're using React, it tends to not always happen exactly the way that I think it will, especially with JavaScript. And because you're responding to user interaction in so many unexpected ways, that having that original fidelity can be super helpful for seeing when I click this button, does this function fire 5 times, right? Is it because, it turns out, I didn't implement this lifecycle hook correctly, or, I have an unresolved response that's been waiting for. And so it just keeps going and going and going until that happens. And being able to watch that unfold and jump to those different executions and see what the values were at different points in time helps me to not only see what went wrong, but also understand how my application is working and why it would do that in the first place.
Mm-hmm. That sounds quite interesting. Also, I heard a lot of talk about TypeScript. Can you tell me more about it? How did it happen? Why did it happen? What's the deal there?
Yeah, I'm not sure necessarily too much on the history of it. I have seen, for me, the first time that I used TypeScript, it felt like a breath of fresh air, because I was in a very unfamiliar code base. I was trying to add an implementation to an existing application, and I had to do it as quickly as possible. And the code base fortunately had TypeScript. And because everything was typed, it's almost like self-documenting in the way, because usually when I look at JavaScript applications, you could look at 10 different applications and it may look like 10 different languages because there's so many different ways to implement, and there's not a set standard. So you may have different variable naming conventions. You may have different versions of JavaScript being used. You may have different types of function declarations. You may have classes. You may not. You may have different patterns being used, like a singleton or factories. And so depending on the code itself, it could look very unfamiliar if you're not used to it. TypeScript is essentially like the dictionary or the legend, so to speak, of what that code base is doing. So it says this variable should be this function should return this type. And having worked with C#, it felt like I had that kind of guide back, that legend back, and looking in that JavaScript code base. And it really helped me to more easily grok what was happening in the code base, that I could add that implementation quickly. The other thing that it helped with was it helped me feel more confident that my code would actually work, because I had spent all the time fixing the TypeScript compile errors before I actually started my pull requests and ran the end-to-end tests. So even before I got to the testing phase, I had spent so much time fixing all the TypeScript errors that I felt more confident that my implementation was actually going to work when I ran the tests against it, and eventually when I, merged it into production. So it felt like some really nice guardrails, but then also some nice documentation. I think that's the purpose that it served for a lot of developers, is just making JavaScript easier to understand and increasing the confidence that you have when you write it.
I read someone a couple of years ago was complaining about TypeScript, and he actually said, I am not kidding, he actually said on Dev, "Oh, you shouldn't turn on TypeScript. When I did that, it filled up my code with lots of little red squiggles." And I said, if your code's filling up with little red squiggles, it's not the tool that's the problem.
Yeah.
But I think some people may be afraid of TypeScript because they think, well, this is throwing away the dynamic typing of JavaScript. What would you say to such a person who is afraid of that?
Yeah. So, I think to your example there, right? Like to me, error messages are a gift because if I get an error message, I'd rather the error occur on my machine than my end user's machine. Because if it occurs on the end user's machine, number one, it's going to be harder to debug because I'm not on their machine. And number two, they're going to have a bad experience. And so I would much rather catch all of those as early as possible, even if it feels like it's slowing down the developer velocity. But in terms of the dynamic aspect of JavaScript, TypeScript allows you to handle for those situations. But I think it just requires you to be more decisive around your implementation and think more specifically around what your application is actually supposed to do. I think with JavaScript, it's kind of there's so many different ways to do things, and you may have multiple developers in the same project who would implement things in different ways. And with those safeguards in place, you can still be dynamic. You can still say, okay, we can have multiple types that may return this. There's union types. You can even use logic to determine what type of what type it may need to return, depending on what's happening inside the function. But you do have to think through that in advance, which I think is where people don't like to do that. They like to just get it working and then call it a day. And so it requires a little bit more forethought. But I think at the end of the day, you end up spending less time debugging, and then your users don't have to encounter those bugs. And, I think that's what some people like to build, just to build and enjoy that process. I think thinking about who's actually going to end up using what you're building, TypeScript forces you to do that a little bit more.
Well, and I guess not to sound I don't want to sound gatekeepery, but I guess that's what separates out the coder from what was historically pejoratively called the script kiddie. Because the script kiddie just wants to produce something, and they like the feeling of being magical. They like the feeling of just being able to type words on the screen and make it do something, whereas the developer wants to do it right. And I say this because I've heard some JavaScript developers complain, I don't like other languages because JavaScript's magical. It just figures out what I want. It's well, it's not magical. It's trying to infer what you want, but it's in that inference is some danger. You get some of this with Python too, because this reminds me of Python type hints. And same story, you can provide a type hint in Python where you say this thing is not, and then a type, you can say something like, oh, this is supposed to be an iterable, or this is supposed to be a collection, or this is supposed to be, something numeric. And you're able to describe the types in terms of their expected behavior. But like you said, you still have to kind of think about that. And I see a lot of, I guess, very beginning developers who don't like having to do that thought. They prefer the feeling of being magicians, I guess.
Yeah. And there's space for both of it. I think when you are learning, it is fun to, again, if maybe you haven't been exposed to that magic of I wrote something and something happened because of it. There can definitely be a place for that. It's when you start to think about what am I building and who is it for, that you want to be a little bit more intentional. I think a lot of it's just the intention, right? If I'm just building something that I'm personally going to use that are just for fun, or if I just want to try out a new implementation or a new pattern, or I just have an idea and want to sketch it out and see if it'll work, then yeah, just throw together get that initial thing working, put the rubber bands on there and get it running. But then as you kind of mature in the program or the product or whatever it is that you're building, then that's where that intention really comes in handy. And, I did a coding boot camp. I actually have known HTML, CSS, WordPress, PHP for a very long time since I studied that in college, but then wanted to learn JavaScript and kind of more front-end frameworks. And so I did a coding boot camp, and it was interesting to see how you're taught and the order of operations that you're kind of taught for a lot of things, because a lot of it is the minimum understanding to get something working versus later on understanding more, that's what that means, or that's why you would do a callback, or oh, I see. Like that's the difference between this and this like implementation. That just takes some time, I think, to absorb. And once you understand that kind of deeper level of not just like what it does, but why it does it and how it does it, that you can be more intentional in making those decisions. Because I think initially you're just like, I know one or two ways to get it working, and that's what I've always done. And once you start to identify the patterns underneath the hood, then you are more equipped to kind of choose the best one for whatever the job is. So yeah, it's interesting. I've seen a lot of different code bases. So at Cypress, I help people implement Cypress into their projects. So you see a lot of code bases. I advise them on how to test it, how to set up their approach to testing their applications. And then I've also done a lot of debugging of applications. At helping people kind of understand what was going wrong in their applications. And so I've seen a lot of code bases, and there's a lot of different ways to do things. And over time, you start to see that certain patterns can lead to certain types of bugs. And there's a lot of bugs that will crop up with that kind of tend to coincide with certain implementations or patterns. And that really helps to kind of reinforce the importance of doing things the right way for what you're building.
That's $468 raised so far, and we still have a lot to sell. Yes, that's after currency conversion. Don't worry, I've got this.
Catherine Goebel Johnson was pretty disappointed she couldn't take the TI Inspire graphing calculator back through the portals to 1963. Turns into an adding machine, but she says it's a pretty nice one, so it all works out. By the way, any ideas for a special today?
I've had a few requests for the future framework frappe that Cecelia ordered, so we could do that. Cinnamon, hazelnut, and vanilla. It's pretty good, actually.
Works for me. Uh-oh. I'd better go see what Nikola Tesla is putting on the table. Some of his prototypes are a bit too adventurous to sell.
You mentioned patterns. Can you tell me more about which patterns to avoid? What's the most dangerous kind out there?
Yeah, absolutely. So there's a lot of patterns that can lead to certain classes of bugs. And typically they're related to how you may implement things. So I work with JavaScript frameworks in particular, and some of the patterns are specific to frameworks. Some of the patterns are specific to any type of JavaScript frameworks. And so the first one that I see a lot, which is kind of more of a general abstract one with working with frameworks, is using the framework in an anti-pattern type of way. So using the framework in a way that it's not intended or trying to customize the framework and work against it. So sometimes you'll see this when you have somebody moving from one type of framework to another. For example, if I worked with Angular first, and then I went to React. And early on, I was like, this is kind of like this is goofy. I don't know how to, I'm not sure about this, but I'm comfortable with the Angular way of doing things. So I'm just going to kind of do a little wraparound, or I'm going to write this in a way that makes me feel comfortable as a developer, but isn't necessarily the right way to use the framework. And that can lead to a lot of issues. I've seen people like overwrite error messages and suppress them, and then you lose them. I've seen people try to implement over complex state management and not working with the framework itself. A lot of times people will implement like a state management tool instead of, maybe they don't need one yet. They can just use the kind of built-in functionality. And so I think the first one that I've seen a lot is just is fighting against the framework, I guess I'll say. And with that comes, understanding the component lifecycle. Well, for whatever framework you're using in JavaScript, they're all component based. And understanding the interactions between the framework and then what actually gets rendered to your application, that is a massive source of bugs. And using those and kind of patterns in the wrong way. One bug in particular that I worked with the first time I used Vue was I had a library, essentially a resource library, and you could vote up or down. And so you'd have a page with a bunch of cards on it, maybe like, whatever your search results were, let's say 10 cards, and each one you could vote up or down if you liked the resource. I would click a plus sign on one of the cards, and then all the cards in the page would re-render instead of just the one card with that should have the number go up rendering. Obviously, that is a big performance issue, and depending on the user's connection may look a little strange too as it's re-rendering if something kind of is amiss or if they render in different ways. So that was something where I wasn't as familiar with Vue. I was kind of storing everything, all my data in an array, and I was just assigning it and I was using that. And I assumed that it would deeply nest and it would only update whatever value that I updated. So in my mind, I was like, okay, I'm hitting one that's just going to update that component. The data should be able to assume it. So with Vue 3, there is two different ways that you can kind of implement data. There's refs and reactives. And again, kind of was going from previously I was using a state management store, and now I was trying to kind of use the Vue implementation itself. And I was using the wrong one, basically. I don't remember which exactly. I was using a ref instead of a reactive or a reactive instead of a ref. But so the data was not deeply nested for the reactivity. So anytime any one value in the entire array updated, it updated the entire array and everything re-rendered. It triggered a component re-render for everything on the page. So me kind of just not necessarily understanding how the component lifecycle worked for that framework and not using the right framework API for the job is what caused a performance issue there.
That's quite amazing. I had a similar approach because originally in ways down the long time ago, I was a Java developer, and when I switched to Python, not having a typed language was super difficult to me. So I started writing the code in Java way of thinking, basically a bunch of validation code, and my code was ugly. It looked like overbloated Java code. That was, I think, Java 1.5, something like that, so super old stuff. And it took me quite a while to file, I think maybe a month or two, until I switched to Python way of thinking where I'm just going to trust whoever's calling me to not pass crazy stuff.
Yeah, and that's exactly like the same thing I've done before, is just trying to do what I already know versus understanding like what tool I'm using and the right implementation for it. So that's definitely a pattern that I've seen a lot. It actually comes up in testing too, when people would switch to Cypress framework, but came from maybe Selenium or Puppeteer or a different framework. They would use page objects a lot, which I don't know if you're familiar with page objects for front-end testing, but it's essentially a way to store your abstractions with your selectors or any functions that you may use on that page. So if I know that I'm going to be clicking the same button or like validating a header text, or I will have an object that stores all of those values that I can reference those. And same thing with methods. I'm calling a certain method on a page. Very common when it comes to this as like a testing paradigm. But Cypress is a different type of framework, and you don't really need page objects. You can just write it as a chain, and it'll continuously research for the element if it can't find it. And so essentially, we would see people writing all these very complex page objects, and then I'd go in and say, you did not need to do that. And it's actually more difficult because now you have to maintain all those objects that you don't need to. And you're more likely to experience flake if something has been updated that does not reflect the page object. And so you see it with any kind of framework or language or even testing tool, right, is trying to use it in a way that isn't inherent to the tool itself. And so that's definitely a big pattern that I see a lot in working with front-end developers.
You mentioned that about switching test frameworks, and I mean, I'm working in Python right now, and I often will be using PyTest for writing tests in Python projects. But then for this one, I'm using Hypothesis, which is a very different way of thinking. And yeah, it's the same sort of thing. It's very easy in Hypothesis to just sit down and write specific examples all over the place. And it's a shift in thinking to writing instead, like, this is kind of the bound of what I consider to be acceptable testing values. And you want to make that as broad as possible, and then just trusting Hypothesis to generate good test data given these strategies. So you're not specifying data, you're specifying strategies, and it's a very different way of thinking. I mean, I've learned over the years whenever I'm switching either a language or whether I'm switching test frameworks to always go back to the documentation and kind of remember in the one hand how I've done things elsewhere, but try to set that aside and just think about like, okay, assuming nothing. This is my first time I've ever coded in my life. I only know the basic concepts. How do I code in this language? And I will read language specs. I find it's the fastest way to onboard it into my head because I'm just thinking in terms of their structure. So instead of thinking, how do I do this pattern in Java, I think, how does Java handle this problem? That's my approach.
And that's actually what has helped me a lot with debugging. So hypothesis sounds really cool. I want to check that out because I think that sounds like a little bit of maybe a battle between deterministic and non-deterministic testing. And that's really interesting because deterministic testing is kind of what they've talked about for a long time. But now we're getting into more non-deterministic dynamic based on like data models and being able to extrapolate from that what types of things you may need to test. And I think that's the future. You know, I'm curious to time travel and see what that ends up looking like. But when you talk about learning the actual language spec, that has helped me a lot with debugging. One of the things that I have done is actually record my browser session, which using that replay tool records every single thing that's happening, including how the framework is interpreting your code and then showing it on the browser itself. So, for example, if I have a bug in my React and I record the browser, I can actually inspect the React code too and what it's doing. So if there's something where it's like for that view example, the same thing happens in React all the time. I've had a bug where it was use effect, which is it's a lifecycle hook that whenever that will fire based like on the initial component, but then also if any values change, it'll fire again. It'll call a function typically. It can be used a lot of different ways. It can be used a lot of wrong ways, and so I was trying to understand why and when it was firing and what the values were at different times. And I was able to record it and I was able to actually see the React itself, not my code and not the JavaScript, but React itself, the functions that React was calling in order to create the components and in order to create the HTML elements on the page. So I was actually able to find like create element and create HTTP and like create HTML in order to see when it was firing and what the values going into the function, what the parameters were at the different points in time to understand why it was triggering. So not just thinking, how do I use React to do this, but what is React going to do with the code that I write has helped me better understand, not just for debugging purposes, but then going forward, what patterns to avoid and what implementations are less likely to cause bugs. And same thing with Java. I mean, at the end of the day, the kind of interest is all JavaScript underneath the hood, right? Whichever framework you're using. And so then you're beholden to JavaScript and its quirks. I think we've all seen that implementation or the blog post into, oh gosh, I can't remember, but it's something, it's like something is greater than 0 and then something equals 0, but then they're not equal to each other just because of the way that JavaScript like determines what's equality and what's not. Or maybe it's like null does not equal 0 in some cases, but it's greater than 0. I can't remember off the top of my head now, but it's something very quirky. And it just has to do with the actual JavaScript implementation of how it evaluates equality, basically.
On that note, what do you think about WebAssembly? Is it going to change how frameworks and JavaScript languages work?
Yeah, I mean, I think that it's really exciting. Everyone that I've talked to that uses it is really excited about it. I think that there's always going to be, new things that kind of have implementations, and there's new technologies that can definitely make things better. I think what you tend to see is when something new comes out, there's this period of time where it's what's the best way to use this and how can we transition to this, and a little bit of understanding of like what the paradigm shift may be. And there can be a little bit of like a user behavior, developer behavior friction, and kind of understanding what that will look like. I think, going back to TypeScript, that was a good example of initially a lot of resistance seeing it used more and more, starting to better understand how to implement it and what limitations are, and then seeing it improve over time. And I think we're at the point now where I think there's a lot of excitement. And I think once we continue to see more implementations of it, we'll better understand some of the limitations and then can make improvements there and see more onboarding to that tooling versus like kind of what people are doing now. But I think it'll be interesting, but I also am I think we probably just like beginning to understand what some of the limitations and best practices for implementing are going to be to understand the full impact of what it'll be.
Well, and might as well ask you too, what is WebAssembly? Because I hear a lot about it and people have a lot of ideas. And one of the most pervasive ideas about it seems to be that it's some sort of JavaScript transpiler. What is it?
Yeah. So essentially, it removes some of the layers between the code itself and the environment that you're running, and it reduces some of the levels of abstraction. So if you think about how when you have a browser or you have a software application, like when you think about a browser, there's a lot of levels that take place in between from your code itself to how then it's actually at runtime converted or transpiled. There's a lot of different, I'm probably not using the correct terminology, but to where it actually ends up reaching the user. There's a lot of steps that have to take place. And what this does is what WebAssembly does is it kind of removes some of those steps to where there's a cleaner interaction between the environment that it's running in and your code itself. If you think about like graphics and like animations, I think that's something where being able to tap more into the environment that the machine that the application is running on and converse more directly with the hardware or those processors in order to reduce some of those levels of abstraction. You see performance improvements, you see efficiencies there. And that is what WebAssembly is essentially aiming to do, from my understanding, and from people that have used it and have talked about it before and some of the implementations that I've seen. I'd be curious, too, to kind of know if you've worked with it or some of the impressions that you've had so far, too.
I haven't touched it at all. I rarely work in the web space. And if I am, I'm usually in HTML, CSS, and a small amount of vanilla JavaScript. I do remember, speaking of kind of the mayfly mentality of the space, and you mentioned how people get excited and they adopt things like really early on. And I remember when HTML5 first came out. Actually, it hadn't even come out yet. It was still classified as alpha by W3C. And people were trying to build desktop applications in it. And they were saying, don't do this. It's not ready. And no one was listening. But we see that with, and then those same people moved on from the HTML5 obsession to the beginnings of the 10,795 and a half JavaScript frameworks that we have in existence right now. How does one keep from getting sucked into the hype cycle?
Yeah, so that's the thing is, I mean, obviously, the idea with WebAssembly, and I think, is trying to get more of that just like native experience where you don't have all those abstractions, you don't have as much of the performance hits that you do get with frameworks and with JavaScript, because that's a very real thing. Like, I will say, I think there's this kind of discourse lately around developer experience versus user experience, and that some of the more modern tooling and frameworks create a better developer experience, and where it's a lot quicker and easier for me to get up and running and design and develop something, but potentially at the cost of a worse user experience in terms of performance, in terms of the potential for bugs and potential for issues, larger, compiled size binaries being shipped to the browser and that taking longer, especially as we see more people on mobile devices and maybe not always on like the highest speed of internet, right? And so I think developers can get caught up in the hype cycle a lot, especially if it's something that speaks to the developer experience. And I've worked in dev tools pretty much except for my very first engineering position, I have tended to work in dev tools. And that's something that developer experience is really focused on, obviously, is like, how can we make this as easy as possible for the person to build it? Because they're going to make the decision of whether or not to use it. And going back to kind of with that JavaScript, we were talking about how if you want to just build it because it's fun and it's magical, and you want that feeling of, oh, this is fast and magical and it's super easy for me to use as a developer, but you lose the kind of intentionality around what it's going to be like for the end user. I think that can help with some of the hype cycle, is seeing, like, I tend to like to see, like, I see a lot of demos, right, of dev tools and a lot of demos of frameworks. And it's like, what does this look like if I'm a bank and I have to use this framework to build a very complex, secure, performance application that's going to be used by thousands of people with that's in a very regulatory environment. And if something goes wrong, it's very, very bad, And I think that is going to be more of the proving ground for against some of the hype, is when do we actually see how it's used in these like really big, massive, complex applications, and biasing more for the user experience than the developer experience. I mean, it's nice to have both, right? That'd be great. Yeah, I think that's definitely a part of it. I think too, it's like you mentioned, that kind of that magic can feel a little bit addictive, and people, like, when they see something new and they want to try it, and it's a lot of fun, especially if you're learning and everything still kind of feels magical, or maybe if you're earlier on and you're trying to decide maybe where you want to focus. I'm a dabbler, I will admit. I got hazelnut, vanilla, and cinnamon in my coffee, right? So, yeah, so I understand the appeal for sure. But kind of going back to what you said too, is understanding how the framework works and like how the tool works, or how it's implementing what's happening under the hood. That's another way to kind of defeat the hype, is a little bit into being like, okay, yeah, this is how I use it, but how does it actually work? And then you maybe start to see the performance implications, or you maybe start
Magic
to see
isn't free.
Yeah, exactly. And you start to see some of the costs that comes with it, right? So I guess playing around with it, learning how it actually works. We're engineers, right? We like to pick things apart and put them back together. And you can do the same thing with tools and frameworks. And so,
Well, I have a hypothesis now, I think. I wonder if the easier language or a framework, in any capacity, the easier it is to use, the less frequency of bugs you will get, but the more catastrophic the bugs you do get will be. It's the difference between whether you're coding in C or C++. And it is said often it is easier to work in C++ than in C. You will make less mistakes in C++ than in C, but when you make a mistake in C++, you're going to blow your foot off. And I wonder if that's the same. I mean, well, you kind of see that in Python too, like with performance. Python is really good, general case. There's ways to make it about as performant as Java. But if you're going to screw up performance in Python, it's going to be catastrophic. As opposed to if you screw up performance in C++, it's going to take a couple extra seconds.
yeah, I think that makes sense. I think it's also the easier the framework is to use, the potentially harder it is to debug when something goes wrong, because there's so many layers of abstraction, or it's so much is abstracted away, that if you don't understand how it works because it's so easy, then when it doesn't work the way that you expect, then it becomes a lot harder to dig in. And because, again, in order to know what's broken, you have to know what working looks like, right? You have to know what it's supposed to do. And if all you know is call this method and the magic thing happens, and I don't have to think about anything else, then when it doesn't work, then at that point, you have to then go back and be like, wait, what does working look like? What is this function actually, or what is this API, method actually doing? And then you have to start from scratch and understanding what working looks like in order to be able to debug it. And because of that, then when something goes wrong, it is more catastrophic, because it could take longer to debug and to find the right solution. And one of the things too I found is that typically when you encounter a bug, and it's because you're using the abstraction the wrong way, it's probably not the only place in your code base that abstraction implementation exists, right? So sometimes I'll find a bug and I'll be like, wait a second, are we doing this for every single section of our app? And then I go and I look and I'm like, yep. We just got lucky that this is the first one that we found, right? And so that can be catastrophic, because typically if you find something that works and you start to implement it, then because of reusability and because you're using, these abstractions across the code base, you may end up finding like 50 instances of it that then you have to determine if there's a better way to implement it from there. So I would agree that it could be potentially a lot more severe, even if it's less frequent.
I want to ask about server-side rendering, because that sounds super crazy to me.
Yeah, so it's funny to me, like server-side rendering, because like I mentioned, like back in the day, that's just like what it all was. It was just like server-side rendering. That's what you do. You just make a call to that page, and then the server gives you the data for the page. It sends it back, and that's what shows up. So I've worked a lot with Next.js, which is a React meta framework. So a framework on top of a framework, or frameworkception, Next.js, and also with Nuxt, which is a Vue meta framework. And they both kind of offer functionality for server-side rendering, also for static site generation. I've used Nuxt more for static site generation, and then I've used Next more for server-side rendering. And yeah, I think it definitely can be a little bit easier to implement. It can be more performant because you're not having as much happening client side in terms of having to like store a lot of data. I will say though, it actually is funny because I ran into a bug with server-side rendering in Next, and it was harder to debug because it was happening on the server and not in the browser. So there's a function called like get server-side props, where essentially when it goes to render the page, you have like props that it grabs, and that's how it determines what to actually then serve from the server to the front end. And there was something failing with the API call there that was happening. And because it was happening server side, I couldn't use all like the familiar browser debugging tools that I'm used to try and figure out what was going wrong. Because normally in a React app, like everything is happening in the client, and I can inspect and I can record and I can do my like logging and everything with my time travel tools. But because it was happening on the server, I lost a lot of visibility into what was happening. So I was still able to debug it. I just had to shift what tools that I used because of where it was coming from. And so that was kind of an interesting scenario that I ran into, where I felt like I had gotten so used to everything happening in the browser, and I had gotten so used to that pattern that when it shifted, again, it's for a better user experience and maybe a little bit worse of a developer experience because it became harder to debug because that was abstracted away. So
I want to ask, you talked about some bugs, but I always like to ask this question anyway. What is one of the weirdest bugs you've ever encountered?
Oh, I don't know if it's weird, but I would say the bugs for me that have probably been the most frustrating are accidental mutation. When I change something that I did not mean to change, which can happen a lot. I think from what I understand, it happens a lot more in JavaScript. I think there's probably a lot of protections around that, maybe in other languages, but
Python's got it too, pretty frequently.
Okay. I haven't done much with Python, but that is something where I would say some of the ones that were the hardest to pin down, and understanding when that mutation occurred, because again, if there's 30 things that may happen when I click a button, right? Understanding, well, what was it that mutated? When did that happen? And what did it mutate from and to? And then first, even understanding that's even what happened. And so those are some of I would say weird in terms of just really tricky to pin down. And also one of those, you don't know it until you know it things. And in understanding the JavaScript and how it handles certain methods will mutate, certain methods won't, and kind of just memorizing what those are. That kind of goes to that weird in the terms of it's just the language doesn't do what you expect it to sometimes. The built-in APIs don't do what you expect them to do sometimes. And you don't know it until you know it. And then because it's mutating, that's going to be the hardest to track down. And then one other one, this isn't actually my bug, but I worked with somebody on it and I wrote a blog post about it, but it was a bug within TypeScript itself. So I work with this developer, Matusz Brzezinski. He's on Twitter and he contributes a lot to open source projects, including TypeScript. And there was a bug with a union type. So a union type essentially allows you to assign certain types based on different types of variables that may come in. So if you have like 3 parameters, you may have like 3 different types, and it uses some kind of logic in order to determine what they should be. And there was essentially a bug where it worked with 3 of the implementations of, it worked with declared function, it worked with arrow functions, and it worked with methods, but it did not work with like const functions or something. It was like there's like 4 different ways to declare a function in JavaScript, and the logic to check for it was implemented in 3 of them, but not one, not the 4th one. And again, super tricky to understand like why this would happen. And Matisse actually used a node runtime recorder to time travel debug this. So wrote a quick test, and then just recorded the execution of that test, but it included the TypeScript transpilation or the compilation. I think transpilation is the right word there.
When it goes from language to language,
yeah,
to going down to bytecode.
Right, thank you. And included that process in the recording. So then we were able to step through what TypeScript code was executing at the time, and able to see that the certain lines of logic ran for 3 of the examples, but not the 4th one. And it's because there was logic to handle methods, arrow functions, declared functions, but not the but not constant, not the last implementation. And so he actually ended up pushing it, doing a pull request and fixing a bug in TypeScript itself. So imagine if you had a bug because of that, and you couldn't figure out how to dig into the internals of TypeScript, right? Probably going to get stuck on that one for a while. So not my bug, but definitely the weirdest ones I've ever seen.
Yeah. It's anytime you run into a bug in the language or the framework, it's always a little bit scary. And it's just a reminder that the more layers of abstraction you have, the more chance you have of an error existing somewhere in that stack.
Yeah, and that's where the time travel can come in really handy.
Yeah, absolutely. This has been fun, but speaking of time travel, I don't know if you guys know, someone just put a laptop over there running Windows 14, which I really want to see what that's going to look like. So I'm going to go check that out, I think. I don't know if you guys want to come with me. I mean, Cecelia, you probably already future jumped enough times to see that in action, but I typically only go backwards.
Yeah, I typically go backwards, do some forwards, but yeah, I'll check that out. I could use another drink anyway. I've finished up my hazel vanilla cinnamon combo here, so.
Well, I will. There's a bit of a line, but I'll have them go get started on that future framework frappe and refill, I think, for both of us, and then let's go see that laptop. Windows 14, what will they do in the future? It's an even number, so that one will probably work.
Bug Hunters Cafe, Jess speaking. Our hours? We are open 24/7 at bughunters.cafe. And you can also find us on Twitter as Bug Hunters Cafe. Yes, the music is provided by audionautics.com. We have a link on our website. Your what? Oh no, it's completely normal for books from the future to be inaccurate. Well, it's because the future isn't deterministic. Butterfly effect and all that. You can have a Chihuahua sneeze in Louisiana, and the end result 4 months later is that the programmer who was supposed to invent some JavaScript framework gets distracted by a bird and creates a birdwatch app instead. Well, it doesn't have to be a Chihuahua sneeze. Maybe you could write that framework yourself. Oh yes, writing documentation scares a lot of developers. But it happens that we're giving away a copy of the book, Docs for Developers, an Engineer's Field Guide to Technical Writing. For your chance to win, just to repost our LinkedIn post about it, and then follow Bug Hunters Cafe on LinkedIn for the announcement of the winner in a few weeks. You too. Bye-bye.